Data Community United for Ukraine. Just let us know in YouTube stream whether you can hear us. Just type something like, I can hear you, and like that. So let us know that we are online and you can hear us. Community United for Ukraine. Just let us know. Yep, sound is good, I guess. Right. So, hello everyone again. Let me just turn on sound. Yeah. Hello everyone again. This is Bogdan Maharos, and we are launching Data Community United for Ukraine. And we have great speakers today. And before announcing our speakers, let me tell you a few things what Data Community United for Ukraine is about. I guess everyone knows that in 2022, Russia started a war in Ukraine, trying to kill people just because they are Ukrainians. And today we are launching the community that helps us to collect funds for Ukrainian Marines. They need a copter that is the eyes for our Marines, and these guys are the guys who are working right now in Kherson, and the copter costs about $16,000. Let me just show you this one. The copter is $14,500, and we started collecting funds for that. And what we are starting? We are starting 3 weeks conference, 9 speakers all over the world who are talking about databases, who are talking about Power BI, and about ML, and a lot of interesting things. Thank you everyone who came today. I see people watching YouTube, LinkedIn, and Facebook. And today we have Dejan Sarka. Dejan is a speaker who you could find at SQL Saturday, being in Lviv or Kyiv. So Dejan, what we are talking today about?
Okay, thank you for this introduction. So we are talking.
Don't forget about Andrea, who we have
no,
today as well.
How can I forget about him? I have to watch him all of the time. Okay, so today I will talk about association rules algorithm, and we will develop it step by step in Transact SQL, and then we'll see how it is implemented also in R, Python, analysis services, even Power BI. One small thing, since we are all Slavic, you could say Dejan, not Dejan. Dejan is my name. Okay, and now I will simply ask Andy. He asked to say a few words in the beginning. Andy, are you ready?
Okay. Yeah. So I want to thank Bogdan, Dejan, and everyone actually that's going to participate in this event. So this is for a good cause. I really hope that things will be better, especially given the most recent news. But in any case, I just want to let everyone know that we in in the European Union, everywhere we are here to stand by Ukraine and to help with anything that you need. Especially our data communities are together. We are united in wishing and helping everyone as much as we can. So thank you all very much for helping, and we hope to see you all, especially in the next few months, hopefully back in the Ukraine as well. Okay, thank you all very much, Dan. Have an amazing session. Thank you.
Thank you. Thank you. Okay, so I will just start sharing my screen so we can start with the session without any further delay. Association rules step by step. And what I will talk about is, first, let me introduce myself. I'm pretty long time in this community. So I work in IT for nearly 40 years already now. And I'm also data platform MVP for like 22 years, MCP even longer. Authored, co-authored 19 books so far, many courses, and I'm focusing from the beginning on data science, from the time when it was called statistics, and then through data mining, machine learning, but also relational data, data quality, data modeling. And similarly, like Andy, I'm extremely happy to be part of this great data community. I also want to thank Bogdan to start this exciting initiative, and hopefully we will collect more than enough money and maybe even repeat it sometimes in the future. So let me now start. What is now market basket analysis? I have just a few slides with a little bit of explanation, and then this is mostly demo based. So we are trying to find out what products are sold together in a single basket or in a single transaction. So in a single order, for example. The algorithm is called association rules. First, we define what is an item. This is attribute value, like product, and value is bicycle. This is an item. Item set is a combination of items that appear together in a single transaction. Basically, it starts in a very simple way. We scan through the data set and count how many times specific item sets appear in how many transactions. Sounds very simple in the beginning, but let me mention that although there's no complex mathematics behind the algorithm, it's still things can become quite complex. Where is the complexity? Well, first important thing to remember is that you will get a lot of combinations. Imagine like a retail store, even some not too big retail chain can have like hundreds of thousands different products and combinations. You can have millions or billions of combinations. Or think about them web sales like Amazon and similar. This could grow this number into billions. So definitely there is no way how you could make it possible to make an overview of all of the item sets you found. So you must find the most important ones somehow. And don't forget that besides positive associations, we also have negative associations. Maybe some product that is sold very frequently looks like it has quite a huge positive influence on some other product, but might have even bigger influence on 2 or 3 other products, negative influence. So you actually, by forcing this product, you're actually doing more damage than good. And also, before even going further, how do you know which rules are valuable? You have to find these valuable rules. Well, first thing to remember is that you shouldn't know this rule in advance. This is also something to remember, because if you already knew that two things are frequently sold together, you didn't learn anything, you just wasted your time. So you are searching for those things that you were not prepared on. But you should always use a little bit of common sense. After all, you are also a human being buying things in same transaction. If you are surprised too many times, you look at the item sets which are the most frequent and say, oh, I didn't know the first one, I didn't know the second one, I didn't know the third one. Then something is wrong, maybe with your data, maybe with you. But if it's too good to be true, then it's usually not true. At least first, most frequent item sets should be already known to you if you're not completely new and strange in some business area. Now let's go and define some measures for association rules. So first we calculate support. We simply count how many times the item set appears in different transactions, and we can express support as an absolute number or as a relative number of transactions with item set compared to total number of transactions. So here we have a very small example, 5 transactions, and we have item set, frozen pizza, and cola. And maybe you can see that frozen pizza and cola appear in transaction 1, but also as cola, frozen pizza in transaction 3. So support for item set cola, frozen pizza is 2 or relatively 0.4. This is support for the item set. Now the question is whether can I express this as a rule, as a sentence, if then. So if product A, then product B. Immediately you realize that this leads to two possible rules. If cola, then frozen pizza, and if frozen pizza, then cola. Support doesn't have a direction, but is there some kind of direction in this item set? What should be treated as condition and what should be treated as consequence? Let's look at another example. Let's look at item set milk and potato chips. So we see that maybe you can notice that this item set milk and potato chips appears in transaction 2. But let's look in which transactions milk appears. It appears also in transaction 1 and in transaction 4. However, potato chips appears only in transaction 2. Let me express this with some kind of probabilities. So if I have potato chips in the basket, then in 100% cases, or with probability 1, I also had milk in the basket. The opposite is not true. If I had milk in the basket, then I had only probability 0.33 to get also potato chips in the same basket. So apparently there is some direction here. And so we can define the second measure, confidence. This is the support for the combination. So the item set divided by the support for the condition. So if I say support for the combination potato chips plus milk is 0.2, we have this 1 in 5 transactions, we have this item set. Support for milk is 60%, 0.6, and support for potato chips is 0.2. So let's see the rule. If customers purchase milk, they will purchase potato chips. Support for item set is 0.2. Support for condition, if milk, is 0.6. 0.2 divided by 0.6 is 0.33. If I turn around the rule, if chips, then milk, then I have support for item set still 0.2 and support for the condition potato chips 0.2. So this gives me confidence 1. And I will stop here and start doing demos. I have still a couple of measures to define, but let's start with demos. And I will develop this step by step with Transact SQL. So here in AdventureWorks DW database, we have two views pre-prepared. Let me just show you these views. So we have two views, ASOC sec line items and orders. We have two views for prepared for demoing association rules. I will just create permanent tables for better performance. So views are quite complex. We have query that joins many tables, and I want to have maximal performance here. So what I have here is line items, and I have order that is defining the transaction. So first I have order SO61313, which has 3 line items, row 350W, cycling caps port 100. So this is this scenario AdventureWorks is this is Microsoft's demo database. AdventureWorks is a fictitious company that is selling sport equipment, bicycles, and other equipment. And with orders, I have basic information about orders, order ID, customer key, also orders are joined back to customers. So we also have some information, demographic information about customers. The scenario here is internet sales. So this information was probably a small questionnaire at the end of the sales. Item sets, I started describing support and confidence, and I used item sets of size 2 items in an item set. However, you can also play with item sets of different sizes. It's not necessary that you always use size 2. You can even start with item sets with size 1, with a single model. This is simply count. So the most frequent product is port 100, then water bottle, then patch kit. Already this gives you some information. And before going to positive side, I will start with negative side. So I will search for models or products that were purchased only once in a single order. So a customer stopped at our website, or maybe I don't know if this would be retail store, stepped into our retail store, purchased a single product and never returned. This is an example of probably little bit negative products. So I will search for those products that have count distinct order number equals 1 and count distinct model equals 1. So this product was sold once to a single customer in a single order. Let's see what these negative products are. And we start learning something. We see that water bottle is many times, very frequently purchased completely alone. Does it mean that this is negative product? You still don't know. This is the problem with association rules. You have to take a view from many different perspectives. Remember, water bottle was also second most frequent product. So 179 is not so big if we look at overall frequency. So the same product was sold nearly 2,500 times. So apparently it is very popular product, and because it's very popular, it's no surprise that it's many times sold alone. In addition, you should always take the results, put the results into real life business perspective. So let's say, okay, it is internet sales, but if it would be a retail store, imagine this situation. You go on a cycling tour and then you realize you forgot water bottle and water. So you simply stop at the first store, buy water bottle and continue your trip. Nothing special here. So I wouldn't say that I can declare water bottle immediately as a negative product. But women's mountain shorts, this is interesting. Many times this was the only product, single product in an order. So apparently this is not so popular in combinations with other products. So step by step, you learn about this products. Now let's do some further analysis since we have region and income group. So let's see what are the most negative products in different regions. I can see like water bottle is very, so I have 3 regions, Europe, North America, Pacific. So apparently water bottle is very negative in North America. Also women's mountain shorts. But this one wrote 750. The distribution is pretty uniform in all 3 regions. So this might be also meaningful that this product is really somehow negative. Let's see for income groups if there are some significant differences, low, medium, high income, and I don't see so big differences as with regions. So apparently income group is not so important. I still didn't do, I'm already talking quite some time, have shown quite a few queries, and I still didn't do any associations. So let's do some association. So let's find support or frequency of item sets with 2 models. What I will do here, I will join line items on the same table again with equal join on order number, and I want to have model from the left different, greater in this case from model on the right. And I got item sets combination of 2 items. So the most popular item set with support 993 is water bottle, mountain bottle cage. Then water bottle, road bottle cage. Now we see that water bottle is actually pretty positive product. It appears in many of these first combinations. Now I will express the same query in another way. Instead of using join, I will use apply operator. So the next query is logically completely equivalent. So I'm using line items and then using cross apply tabular expression, again selecting from line items based on the same order number, and model from the left is greater than model from the right. I get completely the same rules. So these queries are logically completely equivalent. What about physical execution? Let's say the join cannot be slower than apply. So usually from performance point of view, it's safer to use join. But in this case, I would get completely the same execution plan, and apply is somehow more readable for me because it's easier to add the third model. So I will now find item sets with 3 models. So first I find all pairs, and then I simply with another cross apply add the third model. Again, same order number, but model must be different from model from the first reference to line items and different from the model in the second reference to line items. So it's very easy to develop these queries for item sets of 3, 4, 5. So the most popular item set with 3 items is mountain bottle cage, mountain 200, water bottle. Of course, support is much lower than for item sets with 2 items. Okay, now I found item sets, but I said I want to have rules, if then. I will focus now on item sets with 2 items. So for every item set, I can create 2 rules. If A, then B, and if B, then A. So first I will find all pairs, but now I'm using equality predicate for order number, and for model from the left must be different than model from the right. So I will get each pair twice, and I will express each pair as a rule. Let's see this query. And you see for each item set, this is the same item set, water bottle, mountain bottle cage, water bottle. I get 2 different rules. Support is the same for both rules. I have double number of rows compared to the previous queries. Now let's calculate confidence and also support as percentage. So what I need is support for item set and then support for condition, right? So these are rules, but then I need support for condition. Condition is frequency of a single item. So I just calculate frequencies of single items. And then I can calculate confidence, right? As support for combination divided by support for condition. On the top of it, I just used another subquery derived table where I'm just counting all of the transactions, all of the orders. It's 13,000. I need this to express support as percentage. I'm adding this with a cross join. I mean, I could create another common table expression, but since this is not a number that would have influence on development of the algorithm, not important for development of the algorithm, I simply moved it to the from part and derived table. So it will not consider that this number is given 13,006. It will not bother us when queries are becoming more and more complex. So I have first rule, mountain bottle cage, then water bottle. And look, this is sorted by support descending and then confidence descending. Support 993, expressed as percentage 7.63. But look at confidence. First rule, mountain bottle cage, water bottle, confidence is 83%. Second rule, the item set order turned around. If water bottle, then mountain bottle cage, the confidence is 40% only. So less than half of the confidence of the rule that is turned around. So apparently you should first offer mountain bottle cage and then water bottle. You have more chances that the second product will come to the basket. Now we already have few measures. So let's continue with this development. We have support and confidence. And let's find another measure that will also tell me about negative associations. We'll define lift, also sometimes called importance. Let me express this differently. It is always called lift, except if we are talking with Microsoft, then Microsoft is calling this importance. I don't know why, unnecessary new term. Okay, so lift is a general term in data mining, data science. Lift of an item set, A, B, is probability for the combination divided by multiplication of probabilities for both items, PA multiplied by PB. If these numbers are equal, so if the division gives you 1, if lift or importance equals 1, then these two are independent items. So it doesn't matter which one is in the basket. You don't either raise or lower the probability for the second one. If importance is greater than 1, then these two are positively correlated. Having 1 in basket raises probability for the second one. And if importance is lower than 1, then these two products are negatively correlated. So it means if you have A in basket, you are lowering the probability that B would also come in the basket. And if importance, let's say it's greater than 1, the bigger the number, the higher the correlation. Since this is kind of absolute number, it is not like that we would have measures like measures for association in statistics, p-value. We don't have a p-value, but bigger number means simply stronger association. And we have lift. And one more thing, practically one and a half, let's say, not completely two different things, order. we might have even sequential association rules. So this depends if you can rely on order of items in a transaction. If you have a retail store, then you know that order of products in the basket completely changes when you come to the cashier. So you cannot rely upon order. However, we have internet sales. So like line item number, lower number means simply that this item was in basket earlier than item with higher line number. This order must be defined with some sequential number, date time, something like this. So this is a new measure. And what is the half part? You can also add, I mean, it's always possible to see which products have the lowest line item number in a transaction in an order and which highest. So which are starting and which are finishing the shopping sequence. But in order to make this even easier to see those products that are starting and ending the shopping sequence, you can add two virtual products. Let's call them begin and end. And we will assign to this product begin the lowest possible line number and end line number that is higher than any other line numbers in any order. Now you can easily find products that are right after begin. So these products start shopping sequence, and even more important, products that are exactly before end. So it means these are products that are finishing this shopping sequence. So let me go and continue with demos. You see, although it looks initially quite complex, it's not big mathematics behind, and you can really in SQL develop this step by step. So we already have support as percentage, we have confidence, we have item sets, we have rules. So we have all pairs, first common table expression, second, all express them in rules. This is for calculation of confidence, and we calculate the support as percentage, we calculate confidence, and then we simply add lift. So it's support for the combination divided by support for multiplication of supports for every single item in this combination. And this is lift. Now let's order this by lift. The query looks complex, but if you develop it step by step, it is not that big deal. Now we see the highest lift is for this combination, Turing tire, tube. This lift is 12. It is extremely high. And Turing tire, tube has also very high confidence. Support is also not too low. Of course, this is quite logical rule. If you have Turing tire, you also buy Turing tire tube, unless you have tubeless tires. But for Turing bikes, usually you don't have tubeless tires. The real value is usually hidden somewhere lower, where this is combination that maybe you don't expect. Hydration pack, bike wash, lift is 4, right? And let's go further down this table. And here we have some interesting lifts that are lower than 1. So for example, if you have hydration pack in the basket, you are lowering the probability to get also a road tire tube in the same basket. Now we know already a lot of things, but we have also sequential number. The query will be completely the same as previous one. I will even remove lift, so it will be clearer, more clear. Only what happens is this first condition is different. So I have order number must be equal from left and right. Model from left must be different than model from right. But line number from left must be lower than line number from right. That's it. And let me execute this query. I actually removed lift to have at least somehow shorter query and focus. And also I wanted to have shorter result because of big font. So I have now a rule. First mount entire tube, then support 100. Now things have a little bit changed. Overall support is not so high because I enforced sequence, but still high. And confidence, okay, not extremely high, but Sport 100 was also the single most popular product. But now you see the order. And what else you can see? This is an example of a rule that would be very useful if this would be real data, because this is not the rule that you would expect. Think seriously, Sport 100 is a bicycle. Usually you buy first bicycle and then appropriate tube, not vice versa. So if this would be real data, this would be extremely valuable piece of data, right? But since I know this is demo data, I can only say, okay, Microsoft, you could prepare demo data slightly better. You know, it is not bad, but it's still not completely plausible. But you see, this is how you analyze. You must always use common sense. And by the way, I'm not really criticizing Microsoft. Preparing good plausible demo data is extremely hard work. I know, because in late 80s there was still socialism also in former Yugoslavia. So, you know, I was working in university, Institute for Sociology, and we got orders from the government, like do this analysis, do this research. This is what you are analyzing, and this is the desired result. Now you have two possibilities. You can include, I don't know, 20 people in the research, do some polls, live polls, online polls, spend a lot of money, and then realize that you didn't get desired results. Or you can just create the data and divide the money among a couple of people only. And of course, we did the second thing, since we are from Balkans, and I was the one who had to prepare the data. So data that was really mimicking serious polls. So I know it's a really hard job, but believe me, I did it better than Microsoft did it. It was more plausible. Now let's find this ending products. So line numbers maximally is 8. I have maximally 8 products in an order, and minimum is 1. Right? All orders are all together. We already know these are all orders together. They are 13,006. And let's say check how many line items are. We have 32,166 line items. So let's insert in every order product begin with line item number 0 and end with line item number 9. I can have some gaps between line numbers like 1 to 0, 1 to 3, and then 9. And of course, this is double the number of orders, 26,012 products inserted. Let's see what I got. So my first order has now 5 products, 1 to 3 line items. This is like before, row 350W, cycling cap sport 100, but also begin end. And sport 100 is the finishing article that is finishing this sequence. So let's calculate now sequential association rules together with this begin and end. And now let's see, okay, the most popular is begin before end. Yes, we already know this. But this is very significant. Look at the confidence. So sport 100 is very, very well connected with end, not so well connected with begin. So apparently sport 100 is also quite negative product. We already saw this. So apparently you should be careful not to offer it too soon in this shopping sequence. Anyway, we already know that this is not really plausible, not really realistic, because typically you don't start buying accessories and then bicycles. You start with bicycles and then you buy appropriate accessories. Anyway, these are the numbers, but I'm not finished yet. We calculated everything we need. We can now analyze everything with Transact SQL, but let's jump to other platforms and languages. So let me go and analyze the same data with R. And now in R Studio, and you will see I will add some value in R. So I will use library A rules, which has this algorithm implemented. I will connect to my SQL server and read this association rules, these line items. So this looks like a table. Let me just mention that in R we are analyzing data frame. Although it looks like a table, it's something in between matrix and table. Matrix has positional access, order preserved, but all data must be of single data type. Table, each column has own name, different data type, but order is not preserved. The data frame is in between, so each column has different data type, different name, but order is preserved. In a data frame, you can access data in a sorted way. You can access it positional. Okay. I can even you can even use Azure machine learning for association rules. Let me just connect to my Azure Machine Learning Studio. I will not even save the dataset. I already did it in advance because you know that these transfers always take some time, so I didn't want to lose too much time. And for this demo, I'm still using the old studio, which is free. I don't want to spend too much money for just this demo. Yes, it will expire in 2 years. Who cares? I didn't want to go there. And another warning. Okay. And here I am. And here is my association rules experiment. I will come back here in a minute. So let's, I will not execute this because I already exported the data and loaded it to Azure ML. Now I will split this in transactions. So I will define that order number defines transactions and I will analyze model. So let's see some information. This is sparse matrix with 13,006 transactions and 37 different models columns. So this is inspect couple of transactions, couple of orders. So for example, SO61320 has these 3 products: mountain bottle, cage, sport 100, water bottle. Let's see the size. Size is 2 items, 3 items, 3 items. Now I will use a priori algorithm, feed it with transactions, and these are hyperparameters. I'm searching for item sets with minimal length 2, support at least 0.03, and confidence at least 0.05. And I want to see rules, not just item sets. So let's do it. And I have my class rules with many different sub-objects. So let's inspect these rules with rule separator. And let's see first few rules. Let's enlarge this window. So I have mountain tire tube with this support 0.33, and this counts. It's not sorted by support. Look, this on 15th and 16th place is the most frequent pair. It is mountain bottle, cage, and water bottle. So numbers are of course completely the same as we got them with Transact SQL. So let's find support for most frequent items with eclat function. These are set of 14 item sets. Let's inspect them. So these are most frequent items. Again, they were not sorted, but I can see that Sport 100 is most frequent. Also, water bottle is most frequent. Let's now sort them and plot the top. And so this is sorted frequency graph for the most popular items, Sport 100, water bottle, patch kit, and so on. Now let's sort them by confidence and inspect them. And here are the best rules based on confidence. A road bottle cage and then water bottle, confidence 0.89. Let's sort them by lift. And we got our interesting pair, lift 12, Touring tire tube. So far, there was no additional value in using R compared to Transact SQL, but R has also some plotting capabilities. So let's load library A rules with, and this one overloads plot function, so we can also feed it with association rules. And here are these rules represented graphically. Okay, let's wait a second till it renders. So size of these bubbles is based on support, and color, darker color means bigger lift. And what we can see also graphically, the most important rules, we can see this this group here, touring tire tube. This one has the highest lift, but they are not really well connected to other things. On the other side, I have this combination, mountain bottle cage and water bottle, right? This combination, let's square it, which has the biggest support, the biggest bubble. Also, what is worth mentioning is products that are kind of transitional products. Let's take a look at this one, Mountain 200. So this one is a transitional product from Sport 200 to fender set, but also to mountain bottle cage. So this one, although it's not so well connected with any of these products, mountain bottle cage, fender set, Sport 100, these bubbles are small and not too dark. It is still important because it's kind of transitional product. So if somebody purchases, like, I don't know, fender set mountain, then you probably want to offer 1 to 200 because you hope that you will get either in this direction to mountain bottle cage or in this direction to Sport 100. So these transitional products are also important. And we learned something new. Now, what else? I can also use this a priori function to define also what is on left-hand side. So right-hand side, left-hand side can be anything, but right-hand side would be Sport 100. So which products are leading to Sport 100? And I see that the first product is road tire tube, then mountain 200. These are products that lead to Sport 100. What is the opposite? Which products were purchased after Sport 100? Let's see. So also support is much lower, confidence is lower. So Sport 100, remember, this was pretty negative product that actually finished shopping sequences. So you see that we have also learned some new information compared to Transact SQL. So far, so good. Only great things. So you know that life doesn't consist from great things only. So let's also show some negative options, bad options to do association rules. So you are very welcome to do association rules in Transact SQL, in R, but not too very welcome in Azure ML. We have here machine learning. I mean, let's say initialized model. We don't have association rules algorithm out of the box. So what I did here, after I imported the data set, I simply used execute R script and library A rules, defined transactions, and even library A rules with, so I can visualize also the output. And basically this is it. You already know this graph. So Azure ML, nothing new. I just used R. Is this the only bad way? I mean, bad way. It's if I have to do it in R, then I would do it in R. I don't need to go to Azure ML and even not to the new one and even pay for this training when R is free, right? But it's not the worst thing. It's not the worst thing. Let's show this one. What is this one? This is Python. What is wrong with Python? You know that Python is great. Yes, it is great for many things, but not for association rules. At least I don't know, maybe, you know, it has also additional libraries. Maybe there is some other library where association rules are implemented in a more efficient way, more efficient than in this library a priori. It has name Py, like Python, instead of a priori. Look what I defined, transactions as a collection. I have 2, 4, 6, 8, 10 transactions only. Why? Because this algorithm, I will use this function, is extremely slow. A priori function with minimal support, minimal confidence, but only on 10 items. Okay. Execute the whole row. And now what I get is some kind of object, collection of objects. So I need to extract the rules from an object, even code, and I need to do it in a loop. So even the code is not simple, but here are my rules, but they make not much sense because I have few transactions only. But I have this like left-hand side short sleeve classic jersey, right-hand side sport 100, road tire tube, support 1 in 10, confidence 1, lift 10. Why is this slow? I mean, with 10 item sets, with 10 orders, you couldn't see that this was very slow. Well, if you use loops instead of matrix operations, it is always slow. For Python and R, matrix operations are similar thing like set. I wanted to say 6 operations. Set operations for SQL Server. You know that if you are doing things in SQL Server row by row with cursor or with while loop, it will be very slow. The same thing is true for R and Python. You should use matrix operations. Matrix operations are built in core R because this is language that is targeting statistics and data science. For Python, you get matrix operations only with NumPy library. And then on the top of NumPy library, you use pandas library, which brings the data frame object. The vast majority of algorithms implemented in Python are using pandas data frames and are fast. But this a priori library is not using pandas data frame, so it is slow. So let me import NumPy. Now, immediately when it is imported, all operators are overloaded to support also matrix operations. But first, I will define a function that will calculate the reciprocal values of some numbers. So I define this function. Now I will create this 1 million random integers, and I will measure the time. So I will compute them with one by one with functions, the reciprocal values. And let's see how much time will I use. 3 seconds. 3 seconds. Now, remember, all operators are already overloaded because I imported NumPy library. So even division is already using matrix operation. And let's see how long will this calculation take. So it's 0.05 seconds. So it was 60 times faster. Even this simple calculation was 60 times faster. What does it mean? Again, small disclaimer, I didn't check all of the libraries in Python. I Googled for a while and I didn't find anything useful. Maybe there is some new library, but Python is more or less useless for association rules. What about Power BI? What I'm using here is subset of data, association rules. And what I'm using here is I imported a visual, so we have additional visual association rules. And I fed it with data from SQL Server. So let's see this Power Query data. It's just a query. So I actually, let's see the source, it's transact SQL query. I simply copied it, which is already finding all pairs. So it's already doing cross apply. So this is that query, which is finding item sets. And then I get a couple of visualizations like tabular, but I can also, let's go here. I can also visualize it as a graph. It will take some time. I already executed it in advance, so that's why it's fast. And I see somehow similar graph as I saw in R. Are we done yet? Not yet. I can be very stubborn when I start studying something. So where do I have also association rules implemented? In good old analysis services, multidimensional. In year 2005, association rules algorithm was implemented already 17 years ago. What is so great about this? So I created this model. Orders are defining transactions, and then I have line items. And then I defined some hyper parameters no, properties, sorry. I wanted to show algorithm parameters. So minimal support and minimal confidence. Remember, Microsoft cannot use regular names. So you don't see confidence here because Microsoft calls it probability. Support, probability is confidence, and importance is lift. But what is great about it, that we have really, really great viewers. So first we can find these item sets, these rules. So we have rules like road bottle cage and sport 100, then water bottle. And this is sorted by confidence and then by lift, probability and importance. I can also resort by importance. Oh, sort ascending, so you can easily see very negative rules, those that have importance or lift lower than 1. Some are even very red because maybe other numbers are also quite high. So I see also negative rules. And I can see item sets, like item sets of minimal size 2. I can see what is the most important. Then if I go down, I can also see this item set with size 3. So the most important item set of size 3. But the nice thing is this dependency network. It looks similar to that graph in R, just it's even better because it is interactive. So I can also select a specific product and see this is selected node, predict. So this node predicts selected node. So there is no such thing, but selected node predicts this node. So from touring tire, I go well to sport 100 and to patch kit. And in both directions, I can see also these arrows in both directions, touring tire tube. So it is even interactive graph. And I can see also only strongest links. Strength is based on confidence. So it's very, very nice visualization. Now, my last comment in this technical part of the presentation. I know that with SQL 2022, data mining is deprecated. Free analysis services, multidimensional is still there. Data mining is deprecated, so it will not be part of analysis services multidimensional. Yes, 2019 is the last one where we can still do it. I understand this, but what I would really like to see is that these great visualizations are not lost. This is Microsoft proprietary visualization. I think, for example, Power BI could be a great place for such a visualization. It's much better than this one, much better than anything we have in Power BI. Let's go here and let me mention something to tell you some story. Maybe you know this visualization, which is now already included in Power BI. It is called the composition tree. Let me tell you something about this visualization. Since I'm pretty long in this business, I know the whole history of this visualization. So first, analysis services called OLAP server came in with SQL Server 7.0, 1998. And immediately when it was out, there was already great client tool prepared. Company was called Gnosis and client tool was called ProClarity. And immediately in first version, this tool had the composition tree. Very, very great, very advanced interactive visualization. And this was, Gnosis did also some other things, other products, but ProClarity was so successful that they after all renamed the whole company to ProClarity. At some point, I think 2004, something like this, after Excel 2003, Microsoft acquired Gnosis or ProClarity at this time. Acquired ProClarity, and we were thinking now this would be a great fusion, but no, Microsoft wanted to force Excel. So it simply shut down sales of ProClarity Cloud. And it took them 15 years at least before they realized that this decomposition tree is really a great visualization and implemented it in Power BI. I really hope that visualizations, not just for association rules, also for decision trees, clustering algorithms, from analysis services, data mining, analysis services, multidimensional data mining, will need less than 15 years before they appear in some other product, before they are reincarnated. Power BI would be a great, great place. This is not really an interactive session, so we don't have a lot of, I cannot answer a lot of questions unless I see something in chat, if Bogdan writes me something in chat. But what I wanted to mention is this. I will show you two pictures and I will ask you a question, but then I will also answer it. So let me show you these two pictures. On the left side is some mountain, and I think you all know this picture on the right side. So what is the association between these two pictures? These two pictures actually have two things in common. And the first thing is name, Crimea. Crimea is mountain in Slovenia, south of Ljubljana. I watch it every single day. And of course, you know what Crimea is, also peninsula in Ukraine. And what is the second thing that these two pictures have in common? Neither one will ever be Russians, ever be Russian. And with this, I would finish this presentation unless there is some question, if Bogdan or Andy can see in some other streaming media. Otherwise, Bogdan, will you take the word, please?
Yes, Dejan, thank you. So before going to any questions, I want to highlight the QR code that you can see on your screen. This is the direct link to Come Back Alive. In Ukrainian, we say Fond Poverny Živim, right? The Come Back Alive Foundation. So all funds are going directly into Come Back Alive for the copter for our marine units who need them very much right now, defending our country in Kherson, are so taking our land back. So thank you, Dejan. That was a great presentation. We had one small question about cola. Yeah, at the beginning, is cola an item or beverage? Cola is an item. I guess you were sharing some data. And the second question is those Power BI those Power BI custom visuals. So the first question is, are they certified? And what about performance of the machine when running them?
Okay, performance is bad. If they are certified, I should check it. I just downloaded them. I mean, this is not a big deal to check. I can, but I mean, you just go to the store and see. I don't know if it's certified or not, but performance is not too good. I would definitely prefer to see the visualization from analysis services imported in Power BI. It's not that bad as Python. It's in between Python and other R and SQL.
Okay. And there is an opinion that custom visuals and data science custom visuals in Power BI are for like general, not professional use. What do you think about that?
I mean, Power BI is a very like a public tool. Like so, yes. I mean, you don't do theoretically. You can do whatever you have. Even in Power Query, you can do transformations with R and Python. Yes, so theoretically, you can do even very advanced analysis. But yes, I agree. Power BI is targeting somehow different population that is not over skilled in programming and probably don't want. I mean, think of it. You need like to read from the source SQL language. Then you do some transformations in Power Query formula language or M language, and then you use maybe R or Python for additional transformations and visualizations. So like 3 programming languages for one association rules of visualization doesn't sound like very simple for end users, right? So yes, I would agree. This is for simple use.
Okay, thank you. I see Andy is here still. So I online.
Of course, this was an amazing session. Thank you very much, Dan. This was spectacular. So for anyone not familiar with this topic, this is an amazing introduction. And Bodan, I still want to repeat that, of course, all of this event is only possible thanks to you. So thank you again for
not only
events
to me,
and to everyone, of course, but especially you. So thank you very much, Dan. Amazing session. Hope to see you soon as well.
Yeah. And by the way, we have Andy. I guess the next week, right? We have. Let me remind you that we have 3 weeks, 9 speakers from all over the world talking about data, databases, data science, somewhere on the edge with big data, and of course, Power BI. And all funds that we collect are going directly into Come Back Alive for this machine that you can see on your screen that flies and helps our soldiers to see the enemy. And thank you everyone for coming today. Andy, thank you for helping in organizing things. Dejan, thank you for coming today, presenting such a great session. And thank you everyone for coming today, and don't forget to subscribe to the channel not to miss the next events, and you can also press notify button not to miss the next events. And we are in LinkedIn, in Facebook, and of course in YouTube, but YouTube lets you not to miss things. Thank you very much. Thank you for coming.
Thank you. Bye.
By the way, this is not a dress code. You can come just in a t-shirt, but I didn't have a t-shirt, but you both had, so I just called my wife to take it. And
yes, we wanted to wear Vishwanka for this event.
Thank you.
Thank you all. See you next event.
Thank you.
Bye.
Bye.
Bye.